Preparation of aldehydes and ketones. Preparation of aldehydes and ketones. First preparation by GRIGNARD reagent. GRIGNARD reagent is the organometallic compounds in which the carbon atom is bonded to metal. Metal is always positive and carbon is negative part. And between carbon and magnesium is the high electronegativity difference presented. Because of that, GRIGNARD reagent releases alkyl anion. Due to releasing of alkyl anion, GRIGNARD reagent is act as a nucleophile. If it is methyl magnesium bromide, nucleophile is methyl anion. If it is phenyl magnesium bromide, anion is phenyl anion, that is benzene ring anion. This is about the GRIGNARD reagent and which release that anion. And next one for the preparation, when GRIGNARD reagent react with hydrogen cyanide. In this hydrogen cyanide, the bond between carbon and nitrogen is highly polar due to high electronegativity, and nitrogen is a high electronegativity element. Because of that, pi electron shifting towards nitrogen, nitrogen gains negative charge and carbon gains positive charge. When this compound react with methyl magnesium bromide is a nucleophile. It releases methyl anion. Nucleophile always attack on electrophilic site of the reactant. By the transferring of negative charged electron, this pi electron completely shifted towards nitrogen. And here magnesium is the positive charged part. This carbon is bonded by methyl from the GRIGNARD reagent, and magnesium is bonded to nitrogen. There is a double bond between carbon and nitrogen. Nitrogen is the minus and magnesium is plus. Br is added. After hydrolysis of this compound, CH3 double bond N, magnesium is bonded by OH minus ion from the H2O due to presence of positive charge, and nitrogen is bonded by H plus ion, it gives imine. And excess hydrolysis simultaneously break this bond, and nitrogen is negative charge, add H plus ion, carbon has positive charge, add OH minus ion. By the breakaging of these bonds, carbon gains two positive charges. These two positive charges are bonded by OH minus ion from the H2O. Finally, CH3, CH, OH and OH, this compound is obtained when imines on hydrolysis. It is the geminal dihydroxy. Geminal dihydroxy is unstable. By the elimination of H2O from geminal dihydroxy compound, we get an aldehyde or ketone. How it is taking place? Here OH group is the present, and in this OH group, carbon is high electronegative. This sigma bond shifting towards oxygen and released as minus. Carbon gains positive charge. To the positive charge adjacent, there is a lone pair of electron on the oxygen. These electrons shifting towards a positive charged carbon here makes a pi bond. Due to formation of this pi bond, oxygen gains positive charge by the donation of lone pair electron, and the sigma electron shifted to oxygen, H released as a positive charged ion. Totally from this group, OH minus ion and H plus ions are removed. Because of that, there is another pi bond formation between carbon and oxygen. Then finally, it gives a aldehyde. So, overall reaction based on this mechanism, we can write the overall reaction when hydrogen cyanide react with methyl magnesium bromide. Simply this negative part of the alkyl group from the Grignard reagent added to the carbon, and by breakaging of complete these three bonds, carbon has one double bonded oxygen. So finally HCH3 double bond O is obtained. This compound also same. So when hydrogen cyanide Grignard reagent followed by the hydrolysis, you get aldehyde. This is the Grignard reagent reaction for the preparation of aldehydes. And next we can prepare ketones also. So what about final equation? Hydrogen cyanide react with ethyl magnesium bromide. This ethyl minus is substituted to carbon and this part is converted to aldehyde. We can get a propanaldehyde. If hydrogen cyanide is the reactant, product is aldehyde. Alkyl cyanide are the reactant. Alkyl cyanides are the reactant. Similarly, methyl is added to the carbon part. After hydrolysis, this carbon has one double bonded oxygen. So break this double bond, add methyl and add one double bonded oxygen. Finally, it gives a ketone. Hydrogen cyanide gives aldehyde. Any alkyl cyanide gives ketone. And next, formate ester. When formate ester react with methyl magnesium bromide, this methyl is added to carbonyl part of the ester. Because of this pi bond and oxygen, carbon is positive charge, act as a electrophile and a nucleophile is added to that positive charged carbon. By the addition of this nucleophile, this ethoxide group is eliminated from the reactant. Finally, we get an aldehyde. Remove this methoxy part, add methyl part. It is formate ester. If the hydrogen is replaced by any alkyl, it is alkyl ester. When alkyl ester is reacted with methyl magnesium bromide, this methyl part based on the above statements and reaction, this methyl part is substituted to the in the place of ethoxide ion. We get CH3, C double bond O, CH3. This is our reactant and methyl is substituted in the place of methoxide. Finally, we get ketone. From the Grignard reagent, hydrogen cyanide gives aldehyde, alkyl cyanide gives ketone, formate ester gives aldehyde, alkyl ester gives ketone. Based on this, if the acid halide react with Grignard reagent, this methyl minus is substituted in the place of chlorine, we get a ketone. It is the preparation of aldehydes and ketones from the Grignard reagent. Final conclusion: hydrogen cyanide with Grignard reagent aldehyde, alkyl cyanide ketone, formate ester aldehyde, alkyl ester ketone, acid halides gives ketone. So it is the preparation of aldehydes and ketones by the Grignard reagent. Next, preparation of aldehydes and ketones by the carboxylic acid. So in the carboxylic acid, The reactant is the